Hi, this video is going to be a comparison between Python using the Pandas library and Julia using the Dataframes.jl library. It's a comparison of their performance and doing some common operations on structured data. I've got all the operations listed out here, and I'm going to benchmark their speed both in Pandas and in Dataframes, and then compare the performance of the two. For Pandas, I'm using a bunch of examples that were created by Greg Retta on his site here. It's a tremendous resource for learning about Pandas, and on this page he has a lot of great examples that involve movies, ratings, and users who make the ratings. Okay, let's get started. I've already pre-populated Jupyter notebooks with the operations that I want to compare, because I don't really want to waste time typing on the video. But I've also downloaded all the data files into this local directory here. Okay, so I've got two Jupyter notebooks, one with the Python 3 kernel installed and one with the Julia 1.4 kernel installed. So for the Python, I'm obviously going to need Pandas, so let me import that. And then the first thing we do here is we're going to read the user's data in from a CSV. I'm using this timeit directive that Jupyter provides to benchmark operations. And unfortunately, I got to run them twice because using timeit, I can't capture the return value for use later. So that's why I'm running it twice here, but I'm only timing it once. So that gave us 9.82 milliseconds. We're going to do the comparison in milliseconds. Let's do the equivalent of imports in Julia here. And let's type in 9.82 milliseconds. And again, we're gonna do just what we did in Pandas. We're gonna read in the user's file and see how long it takes. Okay, so Julia took 337 microseconds. This little Greek symbol mu is for microseconds, and so that that is actually 1,000th of a millisecond. So that didn't even take 1 millisecond. So 337.582. Okay, so significantly faster in Julia. Let's see if that pattern holds up. All right, now we're going to read in from the ratings file. Ratings file has 4 fields: user ID, movie ID, rating, and Unix timestamp. User ID is kind of a foreign key over to the user's data set. Okay, 116 milliseconds. Now, how about in Julia? You take this opportunity to go type that in, 116 milliseconds. Must be a bigger file than the user's. 20.389 milliseconds. Again, significantly faster. All right, let's go and read in the movies data. We're only interested in the first 5 columns of the movies data. Might as well start this in Julia as well. So this this is how we select the first 5 columns. It's interesting to note that in Julia we have one based indexing for array-like data structures and not zero-based. Whether you like that or not is really just, it's just a matter of taste, but it is a difference. Okay, so for Python we got 37.2 milliseconds. And for Julia, 1.068 milliseconds. I think we see a pattern developing. All right, now we're going to join the movies and ratings. Pandas provides this merge function, which kind of abstracts away a lot of the details of the join. We don't have to worry about what we're joining on. It's smart enough to join on the common fields. That took 114 milliseconds. Julia, we have to be a little bit more explicit and say that we want an inner join, and that we want it to join on the field movie ID. Those are just kind of sensible defaults in Pandas, but here we have to make them a little bit more explicit. So what we should have is a single data set that has fields from them both. All right, so that took 44.199 milliseconds. So far, Julia's streak is unbroken. All right, now we're going to take that new data set and join on the users. And we'll do the same thing in Julia. Again, it's an inner join, but we've got to specify that it's on the user ID. So before the previous join, we had ratings and movies, and now we're going to add users in there. So in Pandas, this second join took 153 milliseconds. And in Julia, it took 26.193 milliseconds. Now we can start doing some interesting things. We're going to get the top 25 movies by number of ratings. So Python has a really interesting sort of convenience function. Pandas has a convenience function for this called value counts. And we'll see, and we can then apply this slice operator to the output and get the top 25. So see, that works great, and we got 66.2 milliseconds there. And in Julia, okay, so that took 5.641 milliseconds. Again, much faster than Python, so that seems to be the pattern. Let's see if that keeps up through the whole time, through the whole test. All right, so for operations going forward, we're going to need NumPy, so let's import that. And now here, we're going to get the number of ratings and the mean score by movie. So we're going to use Pandas group by and aggregate to make those calculations. And then we're going to do the same thing in Julia. So notice that Julia does not have the object-oriented style. Structs exist in Julia, but there are no member functions in the same way that there are in Python. So you don't see that dot notation. Again, you know, whether that's a good thing or a bad thing is a matter of taste. So in Python, that took 206 milliseconds. And in Julia, 5.135 milliseconds. Julia continuing to dominate. All right. Now we're going to sort the movies by the mean score in decreasing order. Okay, that took 5.04 milliseconds. And Julia, go and enter that in, 5.04 for Pandas. Let's see what we get for Julia. So the reason that these take longer than their stated times is that these benchmarking tools are running these operations over and over to get a confident estimate in the amount of time that they take. So that's 89.079 microseconds. So not even 1 millisecond. All right. Now we're going to get the IDs of the top of the 50 most rated movies. So that involves grouping the movies by grouping the movies together, finding the size of the groups, and then sorting the size values. Okay, 18.7 milliseconds in Pandas. Okay, and in Julia, 1.306 milliseconds. Again, Julia way ahead. All right. Here we're going to do something that's pretty common. We're going to bin the users by age, and the bins will be 1 decade each. It took 27.9 milliseconds in Python and only 1.739 milliseconds in Julia. So the next thing we're going to do is get the number of ratings and the mean score for each age group bin. All right, fire that off in Python. All right, 33.7 milliseconds. And in Julia, let's enter that in, 33.7 milliseconds. And in Julia, 2.920 milliseconds. So far there hasn't been one operation at which Python has been ahead. Let's see if we can break that pattern. This time we're grouping the ratings of the 50 most rated movies by movie and age group. So in Python this requires two, so in Pandas this requires two operations. We have to set the index of the lens data set, and then we have to use that index to look up the most 50 rated movies, which we calculated, the IDs of the 50 most rated movies, which we calculated earlier. So that's going to be 22.2 milliseconds plus 102 milliseconds. There we go. In Julia, okay, 33.559 milliseconds. Okay, faster for Julia. All right, and now in Pandas, we're gonna use those groups to get the mean score of the ratings for the 50 most rated movies. And the mean score we're going to calculate for each movie and for each age group. So let's see what that looks like. All right, so we can see for each movie here and each age group, we've got a mean score. That took 33 milliseconds. All right, and Julia, that is only 139.899 microseconds. So way faster there. And the last thing we're going to do, last chance that Pandas has, is to rearrange the data so the age groups are the columns instead, in the columns instead of in the rows. This involves calling Pandas' unstack function. Okay, that was pretty quick, 35.1 milliseconds. Julia has an equivalent unstack. So we'll go put our 35.1 in here. All right, 93.192 microseconds. All right, so in milliseconds, it's that. So wow. Julia was 837 milliseconds faster on a total Pandas time of 980 milliseconds. So that's a difference of 85%. And that's massive. And while you don't really notice it while we're sitting here doing these operations one by one on notebooks, if you had a long script or a script that had one of these operations inside a really long loop, you would definitely notice a drastic speed improvement with Julia. So that's some pretty compelling evidence to try out Julia if you use Pandas a lot doing operations on unstructured data. So that's all I really have. Hope that's useful, and thanks for watching.